From 5G networks to aerospace systems, from artificial intelligence to quantum technologies, from behind the scenes of innovations to real-world applications. Welcome to Innovations Unplugged, the Rohde Schwarz technology podcast.
Headlines shout about AI that writes, speaks, draws, even codes. Despite the noise, the quieter story is in your pocket. Artificial intelligence that could make your phone connect better. Hello and welcome. I'm Inga Müller-Siebentop.
And I'm Markus Haller. Today we are talking about the kind of AI you don't notice when everything just works. No dropped calls, no buffering, longer battery. From Mobile World Congress to telecom boardrooms, the buzz is all the same and is known as AI RAN.
That stands for Artificial Intelligence in the Radio Access Network. If that's new to you, think of the Radio Access Network as the front line of mobile connectivity, the antennas and cell sites that link your phone to the network, or actually every device within the mobile comms ecosystem. To guide us through what's hype and what's real, we've invited someone who works on this every day. Joining us from the Rohde Schwarz R&D team is Andreas Oeldemann, an electrical engineer and AI RAN expert. Andreas, welcome to the show.
Thanks for having me. Great to be here.
So, Andreas, let's start with the elevator pitch. What is the general idea of AI RAN?
You mentioned it in your introduction already. These days, AI is everywhere, and it doesn't stop from wireless communication. So the promises of AI RAN is we bring together advanced artificial intelligence with wireless communication, and in the end can deliver better performance, more reliability, and more efficiency for the wireless network.
Andreas, let's take a moment and unfold this word, AI RAN. What is RAN?
RAN is the radio access network, and like the name suggests, it gives the end user the access to the mobile network. So basically, the RAN is the infrastructure that you can see deployed all around us. Think of it as the first mile towards the mobile network and then the internet as well. Look at the rooftops around you. You can see these antenna and base stations everywhere. So it's really the infrastructure that is all around us, our entry point to the mobile network and the internet. In the end, we need to transmit signals over the air from your smartphone to the base stations, and that is a complex thing to do, right? The environment that we have to deal with is complex. We have objects in our environments, we have buildings, we have moving cars, and all these objects, they introduce impairments to the signals that we are transmitting. Yeah. And the job of the radio access network, primarily of the base stations, is to recover these distorted signals. And so far, we typically rely on conventional, handcrafted algorithms to do that. Yeah.
Why is it so much of a benefit to target the RAN for AI to integrate? There are other options. There are other infrastructure parts within this system. Why is the RAN so important, or what might be the greatest benefit here?
I wouldn't say it's only the RAN, right? I mean, we're trying to make use of AI in wide part of the networks today. And AI RAN is only a small part of it. In the end, like I mentioned earlier, when it comes to AI RAN, we need to deal with this very complex real world environments. And here we're really exploring can AI outperform the conventional algorithms and the conventional models that we have of this real world today? So going back to this example of the wireless propagation environment, it changes rapidly when things are moving. Modeling this, predicting this is very, very challenging. And here the big question is, can AI, can learning from data help us to in the end get better performance, better reliability?
Okay. So putting this into perspective, you just said we want to get a better performance and a better connectivity. Honestly, I'm generally quite happy with my mobile connection, how it is like so far. Most calls go through. Messaging has even become a lifestyle for some. If today's radio access network is already functioning quite flawlessly from my end user perspective, at least, I'm wondering where exactly the headroom is. Where does performance still fall short, even in good networks?
So I think we need to talk about new applications that we might want to support with our radio access network in the future. Just think about extended reality, for example. In the future, people might walk around with goggles with headsets on. Such system, increase the throughput demands of your network massively, and 6G and AI might be a step to supporting such new applications. On the other hand, I would argue reliability is always a topic, right? In your introduction, you were talking about call drops. In the end, we want to have a network that is very, very reliable. We want a network that the user doesn't really care about. This is a network that is ubiquitous and that's just there everywhere. And when we can make use, for example, of AI to enhance mobility of users through the network, I think that adds benefit.
Why do we need AI to drive it even further?
So the history is actually pretty long. We have 5G today, the 5th generation of mobile networks. We had many generations before. And this has been developed over decades of time. And so much research has been put into this. But of course, we're still striving to optimize this, enable new application. Optimize the performance, for example. And artificial intelligence in the radio access network might be one technology to bring us there. You have to imagine these base stations, for example, that we're talking about in the radio access network. They are really, really complex devices. You have many, many complex algorithms that are embedded. What the industry is exploring, if going from conventional algorithms to systems that are more learned using artificial intelligence can bring us these performance, but also reliability improvements. So one thing, for example, that the industry is looking into is what we call a channel estimation.
Okay, fill us in.
So when your smartphone sends out wireless signals towards the base station, these signals, they get distorted by the environment, right? You have buildings that reflect the system. You have
passengers
cars moving around.
Cross my pathway.
Exactly. And all these things, they introduce impairments, right? Mm-hmm. And in order for base station to reconstruct the original signal that you transmitted, the base station needs to compensate these impairments. And what it typically does first, it performs a so-called channel estimation. So the base station needs to have an idea, how did the wireless channel between your smartphone and the base station look like? Smartphones, if we want to get a bit more technical, send out what's called pilot signals. So these are signals that are well known for both your phone, but also for the base station.
And it has nothing to do with my actual messaging or actual phone call?
These are symbols, signals that are just inserted in between the data that you want to share. Yeah, and these pilot signals, they allow the base station to determine how has the signal been distorted when it was traveling over the air.
Because at the end, the pilot signal is a pretty specific and protocol-based signal, right? It's like written in stone, kind of how it should look like, right?
It's written in a specification. Yeah, so every base station, every smartphone is aware of that. Now, this channel estimation, when you look at base stations today, that's implemented non-AI. These are the handcrafted algorithms. In the future, maybe artificial intelligence. The big question is here. Every environment has its unique characteristics. Different buildings, different trees, different speeds of objects moving. So what if we could learn such a channel estimation using artificial intelligence and end up with something that is not one size fits all, but something that is really optimized, tailored for the location where your infrastructure is located.
So as of now, just as far as I understood it, when you say or tell us about handcrafted algorithms, you would need engineers, for example, when we talk about more of a mountain area, who is kind of crafting algorithms that are kind of tailored for that region, but that would be a totally different need or requirement for the algorithms when we are not in this kind of mountain area, when we are, I don't know, totally flat without any kind of disturbance. Is that kind of what happens today, that we need tailored algorithms? That would be the best case, but it's always like thinking about balancing out if the requirement is huge enough and the cost benefit may be enough to really tailor it down from or by an engineer?
Yeah, I think that comes pretty close. I mean, 5G today is a very, very flexible system already, and there are so many configurations options that infrastructure that operators can use to actually tailor the system a bit. Yeah, but with AI, we're going more towards something that is learned on actual data, potentially even collected in this precise environment where we want to get best performance.
So real world data and not lab generated estimated data, right?
I think that's the big question in the end. What's good enough? I mean, we all know that artificial intelligence relies heavily on data, and usually the better the quality of your data, the better it gets in terms of quality compared to the real world, the better.
All right. And let's think about Rohde and Schwarz in all of this. We are a global technology company, and we are doing test and measurement equipment. This is one part. We have a part of our group that is delivering cybersecurity and network solutions. We have a long tradition in providing air traffic control systems, so for airplanes, airports, making sure the communication there works. We have a tradition in spectrum monitoring, countering drones. Andreas, how are we involved in this AI run ecosystem?
So when it comes to 5G communication and then in the future 6G communication, test and measurement is one of our primary businesses here. So what we do is we support our customers in making sure that these AI-enhanced systems that they design, that they eventually work, that they deliver the performance that they promise, that they deliver the reliability, and in the end, I think most crucially, that they are interoperable, because you need to keep in mind 5G and probably also 6G communication networks, those are global systems. You have the smartphones and also base stations from many different vendors that need to work together. We allow our customers to test such advanced systems under very controlled lab settings. So we have the possibility to generate 5G compliant signal. We can analyze 5G compliant systems. Our customers can bring this to their lab and make sure that everything works as expected before it's actually deployed and trialed in this real complex real world environment.
So we're kind of synthesizing the signals that are out there, but like pretty precise, right? So we generate the signals, we analyze the signals, we build up some kind of digital twin that are the signals out there. Can we say it this way, or would you describe it any other?
When it comes to testing such advanced AI systems, data is really key. We want to test such AI systems under very realistic conditions. And here's where the digital twin comes into play. In the end, what we want to do in early stages, we want to have digital representations of the environments where we are planning to deploy such AI models. However, simulation is one thing. In the end, we need to do testing, again, in lab settings. And that's where our solutions come into play. So what we are looking into is how can we take digital twins of certain propagation environments, your typical city center, for example, and reproduce such conditions in a lab environment. This could allow us to test that the AI models that we're training really do deliver the performance in this specific environment. And again, we can do this before taking it out in the field, because that's when it becomes expensive. Even though it's in standardization already, it's still a bit out and until we really see first deployments. But we need to think ahead here, and we need to make sure that our test and measurement solutions, that our test and measurement approaches in the end are well prepared and are ready to support our customers.
Just to make it pretty clear, right? So our solutions have to cover requirements of the future, anticipating what we are expecting, like our customers coming to us and asking for, right?
So our ambition, of course, is always to have our test and measurement implementations ready early, right? I mean, we're talking about AI-RAN R&D activities that our customers are working on here. So in many cases, although we don't implement such an AI-enhanced channel estimation ourselves, we need to make sure that our equipment is ready early to support our customers testing their implementations.
So when does AI really arrive for everyone, kind of? Do we need to wait for 6G?
So everybody's certainly discussing AI in the context of 6G. But we actually expect it to be deployed in 5G networks already as well. When you look at what's going on in standardization right now, the first AI native air interface use cases are being standardized already for 5G.
That something is into standardization. Why is that a huge milestone?
So in the end, 5G and also 6G will be systems that are deployed globally, meaning everything needs to work together. There will be smartphones from different vendors. There will be base stations from different vendors. And standardization essentially provides guidelines, information on how these systems can work together. And that's why it's so important that in the end interoperability is guaranteed.
We have learned so much about a radio access network that gets more and more intelligent with AI. And intelligent means more efficient, connections get better. There is another use case turning this argument around. So when we use more and more artificial intelligence applications in industries, or actually in the future ourselves, for now it may only be like ChatGPTs of this world, but there may be other applications coming. There may also be a benefit within the RAN. Can you give us the perspective on that one?
So we talked about applications of artificial intelligence now that hopefully will improve the performance and the reliability of the network. But you as an end user most likely will not see that artificial intelligence is actually involved. Mm-hmm. There are other applications like chatbots, the large language models, video generation that you are doing on your smartphone. There you actually engage with the AI directly. And another topic here, another use case is how can we make best use of our mobile network in the future to support the performance of such applications. One thing is, for example, what computations do we do on device, on your smartphone, and what computations do we do in the cloud or in what is called edge cloud, closer to you, while delivering good performance, but also keeping in mind that you want to have good battery life with your smartphone, making it energy efficient.
So we want to, as of now, we talked about AI that optimizes given RANs, like optimizes what we are used to. And then it also will be important to have a future-ready radio access network that kind of supports every AI application that will be next, right?
Talking about optimizing the performance of our infrastructure by itself using artificial intelligence, we often talk about AI for RAN. On the other hand, there's also the AI on RAN side. So supporting emerging AI applications that are put on top of this mobile infrastructure, basically.
Thank you very, very much for sharing. We learned a lot in this session. about infrastructure everywhere that we rely on every day. And there is some pretty cool technology use case where Rohde and Schwarz directly enables the future, kind of. Thank you for sharing. Thank you for your time being here.
Literally, thanks for having me.
Yeah, Andreas, thanks a lot. I learned also very much, and I'm excited to see what mobile communication provides in the future. And to all our audience, thanks for listening, and make sure if you would like to know more about this topic, check out our show notes. If you like this podcast, don't forget to subscribe.